Now we're going to define the average total cost, the average variable cost, and the average fixed cost. Okay. The average cost, average total cost, equals the total cost divided by quantity. It's the per unit cost. The average variable cost equals the per unit variable cost. It's the total variable cost divided by quantity. And the average fixed cost is the total fixed cost divided by the quantity, which is a constant divided by the quantity. And the average total cost equals the average variable cost plus the average fixed cost. Okay. Now when you have marginal cost, so we'll put in marginal cost. The average total costs look like this. Okay. Average total cost has a bowl shape, again because of diminishing returns, because initially, before you have diminishing returns, the extra output is going up at a higher rate than the cost, so per unit costs fall, then diminishing returns sets in. Okay. But it also has this relationship with marginal cost. That is, average total cost hits marginal cost at its minimum only. Okay. So the only place where marginal cost and average total cost are equal are at the minimum of the average total cost. Okay. The reason is because as the marginal cost is below the average total cost, it's pulling the average total cost down. So just think about your GPA. If you have a 3.0 and you get a C, it pulls the average down. So then you have, let's say, 2.8, and you get another C, that's a 2.0, it pulls the average down. So as long as the marginal is below the average, it pulls the average down. And then when the marginal is above the average, it pulls the average back up. Okay. Now, average variable cost looks the same. It looks like this. Okay. So again, the average variable cost comes down, comes back up, looks like a U-shaped. Again, it's because of diminishing returns. It comes down and hits marginal cost at only one point, which is the minimum of the average variable cost, and then it comes back up, and you'll notice that the difference between the average total cost and the average variable cost is falling, and that's because the difference between the two is the average fixed cost, which looks like this. Because it's a constant and it's divided by quantity, so it just keeps falling. So the difference between these two is this average variable cost there. Okay. So these are what the cost curves look like in the short run. Okay. What about in the long run? Again, notice that marginal cost comes from below, hits average variable cost at the minimum of the average variable cost, hits average total cost at the minimum of the average total cost. Okay. What about costs in the long run? Okay. In the long run, we said the firm is going to be able to choose the amount of capital and labor that minimizes the cost of producing the amount of output. That means in the long run, the firm is going to be able to produce each amount of output for its minimum amount of average total cost. So in the long run, average total cost looks like this. Okay, again, the long run average total cost is the total cost in the long run divided by the quantity. It's the per unit cost in the long run. Okay, and again, it's going to come down and come back up. Now, there's also a marginal cost in the long run, and it also has a U shape, so it comes down like this. It comes through the minimum of the average total cost again. It comes back up. As long as the marginal cost is below the average, it's pulling the average down. When the marginal comes above the average, it pulls the average back up. Okay. Now the reason the long run marginal cost and long run average total cost have a U-shaped in the long run is not due to diminishing returns, because diminishing returns is a short run concept. It's due to something we call returns to scale. So let me define returns to scale for you. Okay. Let's say that we start out with a firm using K1 amounts of capital and L1 amounts of labor, and they use it to produce Q1 units of output. Okay. Now suppose we double the amount of capital and labor in that firm. Okay. If we just double the amount of output we produce, then we say the firm has constant returns to scale. Okay, constant returns to scale, again, means that if the firm size doubles, the amount of output the firm produces just doubles. That also means that there's no cost saving between having one firm get bigger, because if we start with one firm producing Q1 and reproduce it across the street, then society is using double the resources and getting double the output. It doesn't matter if we put those resources in one firm and the one firm doubles in size, we use the same amount of resources and get the same amount of output. That's if the firm has constant returns to scale. But suppose the firm has increasing returns to scale. And by that we mean when we double the capital and labor in one firm, the firm more than doubles its output. Okay? That means that one firm can use those resources more efficiently than two firms can. It can communicate better. Different parts of the firm can work better with different parts of the firm, as opposed to two separate firms producing. So there's cost savings through having one firm get bigger. Okay? So if we take one firm and reproduce it across the street, again, society would use up double the resources and get double the output. But if we put those double resources in one firm, we actually get more than double the output. So in order to double the output, we could use fewer resources. There's a cost savings there. That's when the firm has increasing returns to scale. Okay. Now, when the firm has decreasing returns to scale, it means that now the firm can use the resources less efficiently than one particular, than more firms could. Okay, so now if we replicate the firm across the street, we get double the resources, giving us double the output. Now, if we double the resources in one firm, we get less than double the output. Okay, so there's cost savings to having many, many small firms producing as opposed to having one big firm producing. Okay, that comes about because as any firm gets bigger and bigger and bigger, it becomes harder and harder to keep track of what's going on. So more and more of the new resources go toward administration costs as opposed to actually producing more output. So this is decreasing returns. Okay. If you have constant returns to scale, as you produce more, as you double the resources, you double the cost, and you just double the quantity, so your average total cost stays the same. If you have increasing returns to scale, now you double the cost because you double the resources, but you more than double the output, so your per unit cost is going down. And if you have decreasing returns to scale, as you produce more, your average total cost is going to be going up. So what you get is the shape of the long run average total cost is due to returns to scale, where you have increasing returns to scale where it's falling, constant returns to scale where it evens out, and decreasing returns to scale when it increases. Okay, so the reason you have U-shapes for the cost curves in the long run is because of returns to scale. We also call increasing returns to scale economies of scale. And decreasing returns to scale is called diseconomies of scale. Okay. Now let's look at the relationship between the long run costs and the short run costs. Okay. Okay, I should be able to get this. Okay. In the short run, capital is fixed. So there's an infinite number of short run average total cost curves. Each one depends upon a fixed amount of capital. In the long run, capital is variable, and you can produce the output for the minimum average total cost that's possible. So the long run average total cost is the plotting all the points of the minimum short run average total cost against each quantity that's produced. So it's the lower envelope of all the short run average total costs. And the way to think about this is, suppose you're initially producing at point A, producing Q1. Okay, here the amount of capital you're using is just the amount that minimizes the cost of producing it, because it's on both the short run average total cost and the long run average total cost. Suppose your output goes up to Q2. In the short run, you have to produce keeping the amount of capital constant. So you'd produce at a point like B, which is along the same short run average total cost as A, because your amount of capital is held constant. In the long run, however, you can change the amount of capital, which means jumping to a new short run average total cost, in particular getting more capital, and lower the cost of producing that output, so you move from point B to point C, where in the long run you're on this new short run because you've got more capital and you're producing for the lower average total cost possible. Okay, so the relationship between the long run average total cost and the short run average total cost is it's the bottom envelope of all the short run average total cost.